In today's lesson, we're going to talk about the quadratic formula, which is another way that we can solve quadratic equations. Just like solving with factoring, we need our equation to be in the form ax squared plus bx plus c equals 0. We have to have it equal to 0. And when we have that, we can use this formula right here. And it's x equals, that's our answer, equals the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. And these coefficients come from our quadratic equation once it's set equal to 0. Now, while this formula seems very complicated, one of the advantages of the quadratic formula is that it works for every single type of quadratic equation. So factoring only works if equation is factorable. The square root method only works if it's an x squared without an x term. This formula works for all of them, and I will show you how to solve equations using this formula. But first, we're going to practice simplifying radicals that are a result of this equation, just to show you what you need to do to have it in simplified radical form. When we look at a fraction like this, we're going to start by seeing if the radical can simplify. So I'm going to first look, does 20 a perfect square? Is it along the diagonal of a multiplication chart? It is not. I would see 16 and 25, but I don't see 20 on that diagonal. So I'm going to go ahead and do a factor tree, or break down my 20 into factors. So 2 goes into 20 10 times. 2 is prime, but 10 is not. 2 goes into 10 5 times, and 2, 2, and 5 are prime. So 2 times 2 times 5 makes 20, and these are all. So I know I have all the prime factors of 20. So now I'm looking to see if I have any pairs, and I do. 2 times 2 is 4, and the square root of 4 is just 2. So I found that perfect square. Whatever is not paired up goes under a separate radical. And so the square root of 20 is the same thing as 2 square root 5. So I'm going to take this equivalent 2 root 5 and replace that for the square root of 20. I'm going to make that substitution. That's an equal trade. Once I make that substitution for 2 square root 5 in for 20, that simplified radical form, I need to look at my fraction and see if I can simplify this. And when I have a denominator here, that is the same thing as saying I have negative 4 divided by 2 and plus or minus 2 root 5 over 2. I can split my fraction into two parts and see if I can simplify each side. And so then I can think about negative 4 divided by 2 and negative 2 root 2 divided by 2. And I do have a common factor that can cancel out of each of those fractions. So 2 goes into that negative 4 twice, so I would have negative 2. And 2 and 2 cancels out, so I would have just root 5, and I still have my plus or minus. It is fine for you to write this. Remember, these are two answers. This is the same thing as negative 2 plus the square root of 5 and negative 2 minus the square root of 5. You can leave it in the more compact form with the plus or minus. But you can't simplify any further than this, either writing it in the compacted form or the expanded form, because the radical and the non-radical are not like terms. They cannot be combined in an exact value. Let's skip over to example C, where we have negative 3 plus or minus the square root of 15 divided by 2. And again, we're going to start with looking at the radical separately. And when I look at 15, 15 is not on my diagonal, so I want to see about breaking that down. And it is not an even number, so 2 doesn't go in there, so I'm going to check 3. 3 does divide into 15 5 times. And both 3 and 5 are prime, so these are the only prime factors of 15, and I don't have any pairs. All that means is the most simplified form of the square root of 15 is the square root of 15. So nothing changes, which means there's nothing that divides out in front, which means nothing can cancel with these two numbers. So my final simplified form would simply be -3 plus or minus the square root of 15 all over 2, and I would just leave my answer like this. Again, looking at my quadratic formula here, x equals the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. Sometimes in saying the opposite of b, people say negative b, and they take a negative of whatever your b value is. And just to remind ourselves that we can only use this formula if the quadratic equation is solved so that it is equal to 0. So that is a key idea, just like for factored form. And for any problem, the first thing we do after we see that it is set equal to 0 is we write out what our a, b, and c are. So remember that if there is no coefficient shown in front of a variable, we know that that coefficient is really 1. So my a is 1, my b is -2, and my c is -4. So I'm going to use that formula, and the first thing I'm going to do is either think of this as the opposite of b. So my b is -2, so the opposite of -2 is +2, plus or minus the square root, and now b squared, that's going to be -2 squared. You want to put that in parentheses, especially using your calculator, so that it doesn't inadvertently give you the wrong sign. It's very important to use parentheses when dealing with negative numbers in a calculator. Minus 4 times my a value, which is 1, times my c value, which is -4. And then that's all divided by 2 times my a value, which is 1. Now we're going to do some simplifying. When I simplify everything under the radical first. And you can put that whole thing in your calculator. You can type in exactly as you see it right here, that -2 in parentheses squared minus 4 parentheses 1 parentheses -4. You can put that whole thing in your calculator, and you should get 20 for that value. And then 2 times 1 is 2 for the bottom. So now we have something that looks like what we had up at the top, and we're going to simplify it in that same way. In fact, we just simplified what the square root of 20 was. The square root of 20 is 2√5. So you can use different part of your homework. If you've already done this, or your notes, you have that up there. So from our notes above, we know that the square root of 20 is exactly the same as 2 square root 5. So I'm going to make that substitution right here. And we have x is equal to 2 plus or minus 2 square root 5 all over 2. Because we have a 2 here, here, and here, in all my constants, I can divide out a 2 from all 3 parts. If it is helpful, and it probably is to start, remember this is the same thing as 2 over 2 plus or minus 2√5 all over 2. And so these 2's cancel out, and my final answer would be 1, because 2 over 2 is 1, plus or minus 1√5, or just, you can write that just as a square root of 5. And so that would be my answer that I write up here, 1 plus or minus square root 5. Some students struggle to know how far to simplify. If you get to this part right here where you simplify correctly under the radical and you have everything plugged in correctly, that is going to be 3/4 of your credit. This last part of simplifying is the last part of your credit if you're taking a quiz or a test on this. The last example that we're going to look at for today's video is going to be question 5. So for the video, I was able to copy down our formula so we can see it while we're working on number 5. And I'm looking at my setup here, and I need to have my equation equal to 5, and equal to 0. And in this example, I'm equal to 5. So to get rid of 5, to make that 0, I would need to subtract that 5 away. And if I subtract 5, I have to subtract it to the other side of the equation. What you do to one side, you have to do to the other. Now, 5 right here is not like terms with 3x or x squared. And so that just means that I'm going to write it separately. So I have x squared minus 3x minus 5. None of those terms were like, so we could not combine those together. So it just means that that 5 stays minus 5 on the left side. Now I'm able to say what my A, B, and C are. I cannot say what my A, B, and C are until I have the right side equal to 0. Take a moment to write down the A, B, and C. You can pause for a minute if you need to. So we have A is 1, B is -3, and C is -5. And we're going to plug those values in to our equation up here. So in the first example, I thought of that, or I talked about this as being the opposite of B, which is true, but it also works if you say it's negative of the B value. And so let me show you what that would look like. So I have x equals, and then I have negative b, and my b value is -3. So that would be a negative of -3 plus or minus the square root of, and here I have b squared, and I have to take that -3 and square it. So I'm going to always put that in parentheses, minus 4. This 4 is just part of the equation. That's not part of our a, b, and c. And then times a, which is 1. We have that right here, times c, which is -5. Again, I'm always using parentheses to do my multiplication, especially when I have negative numbers. And that whole thing is all over 2 times my a value, which is 1. And now I can start simplifying. When I don't think of this b as the opposite of b, where I have the negative of -3, you could put that into your calculator. You could do a negative, put a parenthesis and put -3 and close your parenthesis and hit equals. It's going to come out to 3, positive 3. That's the same thing as the opposite of b, which is the opposite of -3, which is positive 3. You know that. I personally like to phrase that instead of negative b as the opposite of b because it saves me a step when I'm simplifying. So that is my simplified first term. Now I have my plus or minus. And remember, we want to do everything under the radical in our calculator at one step using our parentheses. So please do that right now. When you put it in your calculator, you're going to get 29. And that's because -3 squared is positive 9. And -4 times 1 is -4, and -4 times -5 is positive 20, so that 9 plus 20 is 29. Again, you can just put it in your calculator, making sure to pay attention to your negatives and use parentheses. And then 2 times 1, the bottom of my fraction, is just going to simplify to 2. Now I want to look at the square root of 29 and see if that can be simplified. The square root of 29 is not on our diagonal. It's not a perfect square. And there are actually no other factors of 29 besides 1 and 29. We say that that is prime. And so we can leave that. So that means that this right here is our final answer because the square root of 29 cannot be simplified further. And so our final answer that we'll write on our line is simply 3 plus or minus the square root of 29 all over 2. So you are going to continue your practice finishing the top section and working on odd problems.